Hello class. In this lecture I will talk about confidence interval for proportion. So we have previously discussed proportion is fraction, and the formula for it is frequency of an event divided by the total. And again we have so this is when I say confidence interval for proportion, I'm referring to population. So we have previously discussed if this is the population and population proportion is usually represented by P. So we kind of try to take a sample and the sample's proportion is represented by P hat. So one of the examples would be how many people in Killeen likes color red. So that is what we are interested in. So we can, it's really difficult to calculate it. So we take a sample, maybe 100 students, maybe 100 people in Killeen, and calculate how many of them like color red. Suppose 20 people like color red. So out of these 120 likes color red, then the sample proportion would be 20 over 100. So that's how you will be calculating. And then once you have this, you kind of make an inference that maybe this is 20 over 100 is let me calculate what is 20 over 100. So this would be 0.2. So we can make an inference about the population, maybe 0.2 or 20% of the people in Killeen will like color red. So that's how you are making inferences, but we are still, this is a point estimate. So we are just giving a one point, and we don't have confidence about our analysis. So we kind of wanted to give a range for this proportion. So that's the main idea of proportion. So let's discuss the formula for confidence interval for population proportion. So confidence interval for population proportion. So this is for P. The formula is given as, again, P hat minus plus. So we will be using again Z statistic here. So Z alpha over 2 square root of P hat 1 minus P hat over N. So if you see, we are relying on sample data to make predictions about the population P. So let's do an example on this problem, on this. So first thing I will kind of explain this formula. P hat is the sample proportion. and then z alpha over, so n is the sample size, and then this z alpha over 2 is our critical value, and then this whole thing is our margin of error. So now that we know each element in this formula, we will kind of try to solve a problem. So the problem, the question would be, so this is our problem. The question is determine 90% confidence interval for proportion of people who like color red in killing. So we are interested in what proportion of people like color red in killing. So what do? We take a sample. So a sample of say 92 people in killing indicates 45 people like color red. So we took a sample of 92 people and then 45 people said that they like color red. So the first thing is again we took a sample, so our sample size is n, this is all given. So our sample size is 92, and then our x, which is the number of events, so that is given by 45. So if you see this formula which I discussed, frequency of an event, this can also be said as proportion P. If it is a population proportion, it's x over capital N, which is the size of the population is represented by capital N. If it is for a sample p hat, it's x over small n, so where the sample size is represented by small n. So that's the formula I'm trying to use here. So x is kind of 45, we know n is 92, and then they're asking us to design 90% confidence interval. So the first question is, what is the sample proportion? So it's given by x over n, so that is 45 over 92, so this would be 0.489. So that is our, so if you see our formula for confidence interval for population proportion, I will write P, population proportion. So this is, the formula is P hat minus plus z alpha over 2 square root of p hat 1 minus p hat divided by n. So we know 0.489 is p hat, so this is 0.489. Our sample size is 92, so we know all the p hats and the sample size. The only thing we need to know now is our z alpha over 2, which is the critical value. So as we discussed previously, critical value, they are to calculate 90% confidence interval. So our alpha would be 1 minus 0.90, that is 0.10. Alpha over 2 would be half of it, 0.10 divided by 2, which is 0.05. So if we draw our normal distribution curve, so this will be our population proportion curve, and then alpha over 2. So we are looking at where would our sample lie. So this is negative z alpha over 2, and this would be positive z alpha over 2, and this area and this area together would be 0.10. So actually this area is 0.90, and then these two together is 0.10. So this area is 0.05, and this area here maybe will be 0.05. And as you know, we can look at, this is the probability, so we can look at z table and kind of calculate our z value. So go to z table and look for 0.05 in your probabilities. So usually z table gives left side of the curve, so it will give you this value. So I will now go to our statistical table course module, statistical table spreadsheet, and look for z value. So I'm going to modules, and then I go to module 0, calculation aids, and then go to statistical tables. So this is our statistical table. So I am in Poisson distribution spreadsheet, so I need to go to z table. So I go to z table and now I have to look for the value 0.05. So I have to look for 0.05, so I will go and look for a probability of 0.05. So this would be so 0.05 would be either this or this, in between them, so I can take one of them. Usually I tend to take even numbers, that's what I like, but you can take odd also. So this is negative 1.6, and this is 4, negative 1.64 or negative 1.65. So I will go and look for, so this is negative 1.64. So you can take 1.65 also, the answer will be right. So it's not necessary you have to take, but I kind of like even numbers. So this is plus 1.64. So once you get those values, you can kind of now put the formula together. So use this formula and substitute the values. So I will go and put those values. So the formula was again, this is confidence interval for proportion for population proportion for P population proportion. So this is P hat minus plus Z alpha over 2 square root of P hat 1 minus P hat divided by N. So our P hat we got 0.489. So that would be 0.489 minus plus Z alpha over 2 is 1.64. So usually this minus and plus is taken care of by this. So 1.64 multiplied by square root of 0.489 1 minus 0.489 divided by N is I think it's 92. Let me cross check. So that's 92. That's good. So this is 92. So our lower limit would be 0.489 minus 1.64 multiplied by square root of 0.489 1 minus 0.489 divided by 92. So that would give us 0.3719. Our upper limit would be 0.489 plus 1.64 multiplied by square root of 0.489 1 minus 0.489 divided by 92. So that is going to give me 0.6060. So the interval would be 0.3719 and 0.6060. So this is our confidence interval. So what it means is around 37.19 to 60.60% of the people in Killeen will like color red. So 37.19 and 60.60% of the people will like color red. This means the other way interpretation is, if I randomly pick a person, the chance of them liking color red is 37.19% to 60.60%. So this is the concept of population proportion. We can kind of try to solve this problem using our calculation aids. So let's look at the values which is given. So our I will note down those values. Our sample size N is 92 and X is 45 and 90% confidence interval. So N is, so this is calculation aid. So N is 92, X is, I think I keep forgetting those numbers, 45 and 90% confidence interval. and 90% confidence interval. So I have these values. I go to my, I will download the, let me close this. So I will download the calculation aids of chapter 9. And open it. I will do enable editing. Now I can go to, so I am in confidence interval mean known variance spreadsheet. I have to go to confidence interval proportion. Now there are two cases. If your proportion is given, so that means if the calculation p hat, which is 45 over 92, that is 0.489, if this is given instead of these values, then you will be using case 2 in our spreadsheet. So if these values are given, then you will be using case 1. So you go here. So currently these values are given. So I will just type in the number of events, which is the number of events is 45. So this is 45. So I will go here. This is 45. Sample size is 92, I think. Let me go and check. Sample size is 92. So I will go here and do, sorry, I keep getting the right click here. 92, and then I need alpha. So let me check what is alpha. Again, they gave 90% confidence interval, so I will do 1 minus 0.90, that is 0.10. 0.10 is my alpha. So I will go to this and type in 0.10. Hit enter. So you see we got our point estimate, which is 0.489. We got our sample standard deviation, we got critical value 1.64, and then we got margin of error, and then we got lower bound and upper bound. So you can use the case 2 for the same problem if you assume that these are not given. So these are not given, this is given. So I will just put sample proportion here in this sheet, case 2, point estimate of proportion. So that is sample proportion we are trying to enter. So that will be 0.489, and our sample size is 92. So I will type in 92, and alpha is again like the previous case 0.1. Okay. Alpha is 0.1. Hit enter. So if you see, you are getting the same values like sample standard deviation, critical value, margin of error is same, lower bound and upper bound is same. So it's just which one is given, that is what you have to figure out. So now that we did proportion problems, let's go to Hawk's learning and try to solve a problem on it. So here is a problem. We have an auto manufacturer wants to know the proportion of new car buyers who prefer foreign cars over domestic, and a sample of 1519 new cars is drawn. Of those, 425 preferred foreign cars. So, and then use the estimate, using the data, estimate the proportion of new cars who prefer foreign cars. So usually if they might kind of change the problem, who prefer, instead of foreign cars they might kind of say domestic cars. So we will do both ways and see how the results will impact. First thing is let's go here and try to note down those values. Maybe I will go to a new sheet. So this is Hawk's learning question. So the first example I will take foreign car, which is your problem itself. So let me see how many. So sample of 1519, so and then 425 prefer foreign car. 1519. So your N is 1519 and your X, so here X is foreign car, so this is 425, and then let's see what is the confidence interval they wanted us to calculate. So they didn't give in the first case confidence interval, so we just key in those numbers at this time into our this calculation aids. Again I will just close this and open a new calculation aid. Usually when I change the numbers there I tend to make a lot of mistakes, so I'll just download a new calculation aid. So again I'm doing chapter 9. I'll download that calculation aid. So I open chapter 9, enable editing, and then again I am in known variance spreadsheet. I have to go to proportion. So number of events, they gave us number of events, so that is X, so that's 425 is the number of events. So I will type in 425. So this is 425 and this is 1519. I guess that's right. So let me cross check 1519. Yeah, that's right, 1519. So they are asking us, the question is asking us what is enter your answer as a fraction or decimal. So they are asking us to estimate the proportion of new car buyers who buy foreign car. So that is this value, point estimate of proportion, that is 0.2797. 0.2797. So I will go here and do 0.2797 and hit submit. So that's good. So I go to next problem. So what is the lower and upper bound, and they are asking us 90% confidence interval. So this is, I will go here, 90% confidence interval. So this is 90% confidence interval. So again, if they gave us 90%, I need alpha. So that is alpha is 1 minus 0.90, 0.10. So that's what I will go and key in here. So alpha is 0.10 and hit enter. You will get your lower bound. Again, you will have a sample standard deviation. This is sample standard deviation is also called sample error or standard error. So this whole thing is also called standard error. So critical value is 1.64, margin of error is 0.0189, lower bound, again this is what we are interested in, 0.2608. so this would be 0.2608 0.2608, and the upper limit would be 0.2987. So that would be 0.2987 and submit. So in this case, sometimes here they asked only who prefer foreign cars. Sometimes they will change the question. They will give you 425 preferred foreign car. However, they wanted you to calculate for domestic cars. So that would be, so now they are interested in, even though they gave 425 foreign cars, they will ask you what is the proportion of domestic cars. So what you do is your N is still 1519, but X, this is domestic car, it will change. So now instead of 425, you will say 1519 minus 425. So this would be, let me check what would be this value. I will calculate this. So 1519 minus 425. So now 1094. So the proportion p hat will be 1094 divided by 1519. So now in your this sheet, instead of this you will be typing 10, I think it is 1094. So this is for domestic cars. So the proportion would be 0.72, and then your standard error. So the lower bound will be 0.7012 and 0.739. So that's how you will be calculating. So you have to look at the questions carefully. So this concludes our lecture on proportions. Thank you.